All right, so your first lesson in Algebra 1, and we are going to talk about patterns. All right, now I know you're thinking, why in the world are we starting off with patterns? I learned patterns back when I was in like pre-kindergarten. In fact, my daughter came home last year. She was in pre-K, and she came home and she's like, Dad, I learned about patterns. It's like red, blue, red, blue. Yes, that's right. And then she was talking about patterns for like weeks and weeks afterwards. Patterns on shirts and patterns on the ceilings and on the floor. And anywhere she could think of it, she came up with a pattern. So I'm sure that's one of the questions that you're asking today is, why patterns? Okay, well, why patterns? Well, patterns are seen everywhere in the world around us, and patterns in numbers and logic are the foundation of all mathematics. Okay, it's all built on patterns, and I'm sure you're asking again, well, yeah, sure, Mr. Byer, or whatever. Well, let me give you an example. Okay, here you go, solve. Now, hopefully you got 14. Now, there's a couple of different ways that people do it. Some people go 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10, plus 2 is 12, plus 2 is 14, and they get 14. All right, now that in and of itself is a pattern because you learned when you were in kindergarten or maybe even preschool that 2 plus 2 is 4. All right, so that's a pattern that you learned, and therefore every time you heard 2 plus 2, you knew it was 4 because it was always the same. And the same thing for 4 plus 2, which was 6. All right, now some of you said 2, 4, 6, 8, 10, 12, 14. You counted by evens. You saw a pattern that the number was always the same. You just counted that way. Now some of you said, well, how many 2's are there? There's 7 2's, and so you went 2 times 7, which is 14. Again, that multiplication is a pattern, right? Now, if you were to look at the next one, 11 plus 11 plus 11, the easiest way, of course, would just be to count up that there are 7 11s, and 7 times 11 is 77. Well, why can we do that? Well, the reason we can do that is because we learned years ago that when there were groups, and each group was the same, and I had this number of groups, that I could just multiply the two numbers together, and it gave me the same thing as if I counted every single individual item, right? That then gave us a new mathematical function, which was multiplication. All right, so that's kind of the idea. All mathematical functions are built in this way. They're not just, well, because. It's every single time there's a reason why. It works because it's built on these patterns, and hopefully we'll see that as we go through the year. All right, so here's a couple of patterns. Why don't you, when I say pause, I want you to go ahead and pause the video and take a couple of minutes to try to figure these out. If I were in class, I'd give maybe 2 or 3 minutes to try to figure these out. So go ahead, and when you're done, I'll go ahead and go through the answers with you, and we'll go on and try some other ones. All right, pause. Okay, now we're ready, so hopefully you got the answers. The first one here is simple, of course, 1, 2, 3, 4, 5, 6, 7. It's just adding 1 each time. The next one, most people get this one as well. 3 to 7 was, you added 4, 7 to 11, you added 4. Or you can go backwards, 15 minus 11 is 4, find the difference. So each time we're adding 4, so then it should be 19, and then 23, and then 27. The next one's a little bit harder. But this one we're just multiplying by 3 every time, or the powers of 3, 3 to the 0 power, 3 to the first power, 3 to the second power, and so on, or times 3 times 3 times 3. So we end up with 81 and 243 and 729. All right, the next one, 1, 1, 2, 3, 5, 8. You'll notice that if you take the first 2, you get the next one. So then if I take 1 and 2, I get 3. If I add 2 and 3, I get 5. So 3 and 5 give us 8. So 5 and 8 would give us 13 here. 8 and 13 would give us 21. And then 13 and 21 would give us 34 for the last one. All right, this next one follows a pattern of you double it, and then add 1. Or you could, I think you could triple it. Now, tripling won't work, so we're going to double it and add 1. So 2 times 2 is 4, plus 1 is 5. 5 times 2 is 10, plus 1 is 11. 11 times 2 is 22, plus 1 is 23. So then we should get 47, 95, and 191. Now, these ones down here were a little bit different. You've probably seen something like this before. Hopefully you notice that the two numbers on the side multiply to give us the number on the bottom, and they add together to give us the number on the top. All right, so therefore this number right here has to be 3 because 8 times 3 would give us 24, and therefore if I add the 8 and 3 together, I get 11 for this top number right here. All right, well, let's move on to something else. Some patterns don't involve numbers. All right, so again, when I say pause, go ahead and pause the video and see if you can figure these out, and then I'll go through them for you. Pause. All right, so hopefully you had 2 or 3 minutes again to try to go through these patterns. Some of these are a little bit easier, some are a little bit harder. This first one is A, B, C, D, obviously, so E, F, G. The second one is a little bit harder. These are actually the days of the week. Monday, Tuesday, Wednesday, Thursday, so it would be F, S, S. All right, this next one is just the beginning of my last name, so Bywater, B-Y-W-A, so it would be T-T, and if it kept going, it would be E-E and then R-R. I guess you would know that if you didn't know my last name. So hopefully you're learning the last names of your teachers. This last one is, for most people, the hardest one. This is 1, 2, 3, 4, 5, 6. So the beginning letter of each number. So O for 1, T for 2, 3, 4, 5, 6. So therefore S for 7, E for 8, and N for 9. All right, and here's one other type of pattern that we might end up with. In math, sometimes patterns involve shapes, which are visual representations of numbers. Okay, so a lot of times we can simplify a problem by not necessarily looking at numbers, but trying to visualize it some way. And we'll do this a lot in class as well. And so here's 2 different patterns right here. Again, when I say pause, take 2 or 3 minutes to try to figure out the patterns. The top one's pretty easy. The bottom one has easy components, and some parts are a little bit harder to try to figure out. Okay, so go ahead and pause. And now here we go. So hopefully you figured out with this first one. If you want to, there's a couple of different ways to go about it. Some people look right here at the first column. It's 2, and then 3, and then 4. So the next one would have to be 5. And then 2, 4, 6. So the bottom would have to be 8. And you've got 1 box here in the corner. You've got 4 boxes, 2 by 2 here in the corner. You've got 9, which is 3 by 3. So then you'd have to have 4 here, which is in the corner. So really what you should have is you should have a 4 by 4 grid with 1 extra at the top, just like each of these has 1 extra at the top, and then it has 4 extra hanging off on the side. And some people look at it that way too. They just go, okay, 1, 2 by 2, 3 by 3, 4 by 4. There's 1 extra, 2 extra, 3 extra. Okay, so hopefully that gives us the right idea there. And then we'll go on and look at the whole picture here, and we say, okay, for this one, what's happening? Now, I set this one up so that each of the dots does something. Okay, so this dot here on the top moves to the right one, and so that one and the next one are highlighted in the next box. This one, there's 3 then, so it keeps moving to the right. This one is 4. So our last empty box then would have 1, 2, 3, 4, 5 dots. Okay, now if you had no idea what was going on before, maybe you want to pause it again right now and see if you can figure out the other pieces. But let's go ahead and look at the others. So this one, I've got this dot right here, which then moves to the middle, which then moves to the right side, which then, we're not really quite sure what happens. It doesn't just keep moving. There's this one which is pretty close, but I'm not quite sure if that's what's going on. So actually I'm going to wait on that one. Okay, so now I'm going to go to the middle dot. So the middle dot is there, middle dot is not there, middle dot is there, middle dot is not there. So that should tell us that in this one I'm going to have that dot right there. So now I've got the 5 on the top, I've got this one right here in the middle. Okay, and then this dot right here is just there every time. It's not really doing anything. So that dot we're going to fill in as well. And then here on the bottom, you see it's on the right-hand corner, the middle, the left-hand corner, back to the middle. So if we kind of follow that pattern, right, middle, left, middle, probably the right corner. So what we've got now is we've got the 5 on the top, we've got the dot in the middle, we've got this one right here, we've got that one right there because that dot was always staying the same. And the only thing really we have left is determine what this dot was doing. We still haven't accounted for this dot right here, so we can see it starts there, moves to the right one space, moves to the right, and then it starts moving down. And so there's a couple ways. I've seen some people say, well, it's probably just going to kind of snake across this way, which means it's going to be in the middle. Okay, so you fill in that dot right there. Oh, it was already there. And then the other way I've seen people talk about it is, well, it goes from there to there to there to down, so maybe it's just kind of going around the middle here, which means in the next one it's going to be right there, which again is filled in. So no matter what, you probably should end up with about the same thing with these 5 across, and then 1, 2, 3 right there. All right, so that's the visual representations. And again, you could probably model those using numbers, some more complex than others. Okay. Now, that's really the end of this assignment, and is just kind of recognizing different patterns. What I'd like for you to do tonight is to come up with a set of 5 or 6 of your own patterns. You want to come up with a mixture of numerical, alphabetical, and image-based patterns. You're welcome to go online and look at other ones, but I would like the patterns that you turn in to be ones that you come up with. Okay? Just come up with your own patterns, and make sure maybe on the back of the paper or on a separate page, include the answers, because next class we're going to do steps 2 and 3, where you're going to share your patterns. They're going to try to solve yours, you're going to try to solve theirs, and it'll just kind of be a fun chance for us to kind of look at this and try some other patterns that are created by other people. All right, so for tonight, just do number 1. We'll do number 2 and 3 in class. And then for an extra challenge, this website right here has some really cool logic puzzle pattern type things. And so if you want an extra challenge, try that. If you do that, please send me an email with a screenshot of the results, and that's how I'll know that you've gone above and beyond and that you've tried this. All right, and we'll figure out something extra to be able to give you for that. All right, so there you go, and good luck, and we'll see you in class.